Imagine you're standing at a cash register. You're holding a cup of coffee. The little digital display reads $1.99, and you hand the barista a $2 bill.
Yeah, pretty standard morning routine, right?
Right. But now imagine if the barista looked you dead in the eye and said, actually, mathematically speaking, you owe me exactly $2. There is no change.
I mean, you probably think they were joking.
Yeah.
Or, just terrible at basic arithmetic.
Exactly. Because we are so conditioned to see this, hard, impenetrable boundary between a number that is just below and a number that is whole.
But what if that boundary is entirely in your head?
Well, welcome to this deep dive. Today, we are looking at a source that is, it's honestly deceptive in its simplicity. For you listening, we aren't unpacking some sprawling historical text today, and we aren't dissecting a dense 80-page scientific journal article either.
No, not at all. We are examining a highly unique artifact of the internet. It's this incredibly brief web page that essentially acts as a digital traffic cop.
Exactly. We're looking at the Wikipedia disambiguation page for the number 0.99. That is it. Just the digits 0.99.
It sounds so mundane, but it's really not.
No, it's not. And our mission for you today is to discover how this seemingly rigid exact decimal is actually a profound gateway. It's a lens through which we can understand human psychology, the physical reality of global currency, and
the really mind-bending, boundless limits of infinite mathematics.
Right.
By the time we reach the end of this deep dive, you're going to understand the underlying mechanisms of why numbers hold such power over us. Honestly, you'll never look at a mundane retail price tag or even a simple fraction the exact same way again.
Okay, let's unpack this because right out of the gate, we run into a massive contradiction concerning the very nature of this number. This source categorizes 0.99 as an ambiguous number.
Yeah, which sounds completely counterintuitive.
I have to push back on this premise conceptually. How can a number be ambiguous? I mean, the whole point of mathematics, the reason we build bridges and send rovers to Mars using these symbols is that it's an exact universal language. 2 + 2 is 4. It's binary. It's objective.
It is a brilliant contradiction to start with, and you're entirely right to question it. Because intrinsically, the value of 0.99 sits at a very exact microscopic point on a number line.
It's exactly 1/100th less than 1.
Exactly. There is absolutely no ambiguity in its mathematical placement. Like if you are coding a physics simulation, 0.99 is an absolute truth. But the word ambiguous means open to more than one interpretation. It means having a double meaning.
Right, it means the water is muddy. But the best way I can wrap my head around this ambiguity isn't by looking at the math, it's by looking at human behavior.
Okay, how so?
Well, I like to compare 0.99 to like a highly recognizable character actor. Think of an actor who wears the exact same face in every single movie. Their physical features do not change at all.
But they play entirely different roles.
Exactly. Depending entirely on the costume they put on or the co-stars standing next to them in a scene, their entire identity shifts. They become a completely different person. The number 0.99 is wearing the same face, the same digits, but it completely changes its identity depending on the symbolic costume we force it to wear.
What's fascinating here is that the ambiguity doesn't lie in the value itself. It lies entirely in the human application of that value.
Yeah.
The tension we are looking at is between the literal digits, the 0, the decimal point, the 9, and what those digits are asked to represent in human society. We are the ones who make it ambiguous.
We project the meaning onto it.
Precisely. A number in a vacuum is exact, but a number in the hands of human beings becomes a tool, a symbol, in this really complex cultural concept.
And that brings us perfectly to the specific costumes this number wears in the real world. The source highlights how 0.99 fractures into completely different concepts the moment you apply different symbols to it.
The context changes everything.
Right. Let's look at the first major identity. 99%. When you see that, you aren't thinking about a specific tangible object. You're thinking about near totality.
Yes, the percentage symbol transforms the decimal into a concept of probability, proportion, and statistical weight. It becomes a total abstraction.
Like the weather.
Exactly. If a weather forecast says there is a 99% chance of rain, you are dealing with the asymptote of certainty. You are leaving the house with an umbrella. It's a mathematical expression of confidence.
But then the source contrasts that abstraction with two other identities, 99p and 99 cents. Suddenly, we are dragged violently out of the abstract world of statistical probability and slammed right back into physical reality.
We're talking about literal coins.
Right. We are talking about fractional currencies used across the Atlantic from each other, pence in the United Kingdom, cents in the United States.
And this is precisely why a disambiguation page exists in the first place. The source requires this clarification because human beings have collectively decided to use the exact same numerical sequence to represent entirely different structures of value.
It's wild when you think about it.
It is. If you type 0.99 into a database without a qualifier, the computer is paralyzed. It doesn't know if you are talking about the likelihood of a medical procedure being successful or if you're talking about a physical piece of copper and zinc sitting on a countertop.
It's a massive conceptual leap. One identity dictates the statistical success rate of a satellite launch, and the other dictates whether you have enough physical metal in your hand to buy a pack of gum.
Which highlights how heavily we rely on context to make sense of the world. The digits are just an empty vessel. We pour the meaning into them.
Yeah.
The fact that human language is so messy that we use the same vessel for a near totality in statistics and an incomplete fractional value in pocket change, I mean, it shows how incredibly flexible our cognition has to be just to navigate a normal day.
So we've established what these physical currencies are, the pence and the cents. But we need to transition from what these currencies are to how they are actively weaponized against us.
Ah, yes, the psychology of it.
Right. So what does this all mean? The source links these fractional currencies directly to the concept of psychological pricing, specifically defining it as the practice of expressing retail prices as just below numbers.
This is where we start to see the friction between our rational brains and our subconscious behaviors.
Now, here's where I want to push back a bit, and I really want you listening to think about your own habits here. We are all highly aware of psychological pricing.
We see it literally everywhere.
Every day. We've been exposed to prices ending in 0.99 for over a century. If I look at a price tag that says $4.99, I immediately know it is $5. I mentally round it up. I am not oblivious to the trick. So my question is, does this actually still work? Why do multi-billion-dollar retailers still bother using a just below number if the modern consumer's brain has adapted to auto-round 4.99 to $5?
It's a great question. You would think that our awareness of the trick would neutralize it. But if we connect this to the bigger picture, the cognitive science behind how we read, we find that the modern consumer's brain actually hasn't adapted as well as we'd like to believe.
Really? So we're still falling for it?
The short answer is yes. It absolutely still works. And the reason why lies in the mechanics of human vision and processing speed.
Okay, walk us through the mechanics. What is actually happening in the brain when we look at a price tag that says $4.99?
Well, human beings in Western cultures read from left to right. When your eyes scan a price tag that says 4.9, the very first digit your visual cortex processes is the 4.
Okay.
Before your eyes even reach the 9, your brain has already begun categorizing the magnitude of that price. This is a cognitive heuristic known as the left digit effect.
So, because our brains are fundamentally lazy, or let's say highly efficient, we anchor the entire value of the item to that first number we see.
Exactly. We are constantly dealing with cognitive overload. When you are in a grocery store, you're making hundreds of micro decisions.
Right. Which brand, what size, what's on sale.
Exactly. Your brain doesn't have the processing power to do rigorous mathematical rounding for every single item. So it uses a shortcut. It registers the 4, and it anchors your emotional perception of the price to that lower integer.
Oh, wow.
By the time your rational, slower-thinking neocortex catches up and says, wait, that's basically $5, your faster emotional brain has already categorized the item as belonging to the $4 range.
That is deeply fascinating. So the 0.99 isn't just a statement of mathematical value. It's literally a neurological hack. It bypasses the rational gatekeeper.
It bypasses it completely. Retailers aren't pricing things at $4.99 because it accurately reflects the cost of manufacturing, shipping, and a fair profit margin.
Right. They aren't saving exactly 1 cent on shipping.
No. They use it because the visual presence of the 0.99 creates an instant subconscious illusion of a bargain.
Oh.
It signals to the consumer that the price has been aggressively negotiated down to its absolute lowest possible point. It's scraping the very bottom of the integer.
It's a psychological hook.
It speaks directly to our evolutionary desire to conserve resources.
Yeah.
It makes us feel like we're winning.
Which is incredibly humbling. Honestly, we walk around thinking we are these highly logical, hyper-rational creatures who understand that a penny difference is economically meaningless.
But we aren't.
No. Put us in a brightly lit retail environment with a shopping cart, and our rapid processing speed betrays us. We fall for the just below number because our biology forces us to.
And that biological quirk completely dominates our global economic landscape.
Yeah.
It is the human element corrupting the pure math we talked about earlier.
So we've seen how human brains manipulate the concept of 0.99 in the finite calculated world of retail. We use it to create an illusion of being just below a threshold.
Huh.
But here's where it gets really interesting. What happens when we take that exact same human flaw and apply it to the infinite world of mathematics? This is where the source takes a massive conceptual leap.
Oh, this is my favorite part.
It introduces another variation of the number, 0.999, repeating with an ellipsis at the end, just 3 little dots.
Those 3 dots change the rules of the universe entirely.
They really do, because we just spent all this time establishing that 0.99 is the king of the near miss. It is the ultimate just below number, but simply adding that repeating concept completely shatters everything we just talked about.
It breaks the intuition.
Exactly. I was trying to come up with a way to visualize the difference between these two numbers, and I think it helps to think about physical space. Imagine you're standing in a room and you start walking toward a wall.
A classic thought experiment.
Right. First, you cover 90% of the distance. You're getting close. Then you cover 9% of the remaining distance. You are even closer. Then you cover 0.9%.
You're getting incredibly close to the wall.
But you can keep taking smaller and smaller steps, 0.09, 0.009. The physical limit you are hitting is the wall. The wall represents the whole number, the 1.0. As long as you are stepping in finite increments, which is what 0.99 is, you are always getting closer, but you never, ever touch the wall.
You are always just below it.
Exactly.
That is a perfect representation of a terminating decimal. The number 0.99 stops. It is stable, it is measurable, and it leaves a gap between itself and the wall.
But the repeating sequence, the 0.999 going on forever, means you never stop taking those microscopic steps. And my understanding is that in mathematics, that infinite sequence means you don't just get infinitely close to the wall, you essentially touch the wall.
This raises an incredibly important question about the mechanics of infinity. And it's a concept that human brains actively rebel against.
Oh, absolutely. My brain hates it.
We intuitively want to treat 0.999 repeating like a just below number. We want to think that no matter how many nines you string together, it will always be infinitely close to 1, but never quite reach it.
Right, because it's a 9, not a 10.
But that is the illusion of infinity. In the rigorous logic of mathematics, 0.999 repeating is not almost 1. It is exactly equal to 1.
Okay, you have to prove that to us. Because logically, if there is a 0 in the 1's place, my brain refuses to accept that it is equal to 1. Walk us through the actual mechanism. How does 0.99 repeating equal 1?
Let's do a simple, accessible proof using fractions. Think about the fraction 1/3. If you convert 1/3 into a decimal, what is it?
It's 0.333, with the 3's repeating indefinitely.
Correct. Now, if you take that fraction 1/3 and you multiply it by 3, what do you get?
Well, 1/3 times 3 is 3/3, which is exactly 1 whole.
Exactly. So if we perform that exact same operation on the decimal equivalent, we have to get the same result. If you take 0.333 repeating and you multiply it by 3, you get 0.999 repeating.
Oh, wow.
Since the mathematical operations are identical, the results must be identical. Therefore, 0.999 repeating has to be exactly 1. They are two different symbolic representations of the exact same underlying value.
Okay, that is beautifully simple, but I know some people listening are still skeptical. Is there another way to prove it? Maybe algebraically?
Absolutely. Let's use a bit of basic algebra to show how the infinite nines grow the gap. Let's say we create a variable. We'll call it x. And we say that x equals 0.999 repeating.
All right. X equals an infinite string of 9s. I'm with you.
Now let's multiply both sides of that equation by 10. You multiply 0.9 repeating by 10, you just move the decimal point 1 spot to the right. So 10x equals 9.999 repeating.
Okay, yep. 10x equals 9.999 repeating. Got it.
Now, we take our new equation, the 10x equals 9.999 repeating, and we subtract our original equation from it. Remember, our original equation was x equals 0.999 repeating.
Okay, so doing the math, on the left side, 10x minus 1x leaves us with 9x.
Exactly. And on the right side, we have 9.99 repeating minus 0.999 repeating. Because both sequences of nines go on infinitely, they perfectly cancel each other out after the decimal point. The infinite tails disappear entirely.
Wait, really? So 9.99 repeating minus 0.99 repeating just leaves you with exactly 9, no decimals at all.
Precisely. So now our equation is simply 9x equals 9. Divide both sides by 9, and you are left with x equals 1. But remember, at the very beginning, we defined x as 0.999 repeating.
Therefore, 0.999 repeating is undeniably mathematically identical to 1. That is incredible.
It's elegant, isn't it?
It completely rewires how you perceive the value of a number. Sitting right next to each other conceptually, we have 0.99, the ultimate symbol of being just below a whole number, the king of the near-miss retail bargain.
Yeah.
And then we have 0.999, repeating a number that looks almost identical to the naked eye, but mathematically represents reaching the absolute destination. It represents the whole.
It shows the staggering spectrum of meaning contained within the application of a single concept. I mean, you add an infinite sequence, and you transition from the cognitive biases of consumerism to the fundamental proofs of algebraic logic.
It really is the ultimate journey. Let's synthesize what we've uncovered today because we have covered a massive amount of conceptual ground.
We really have.
We started with a source that is, by all accounts, just a brief navigational tool, a digital crosswords on Wikipedia. But by unpacking the implications of those few short lines, we've seen how the exact same sequence of digits acts as a mirror for how humans process the world. We've seen how 0.99 bridges the gap between the near totality of statistical probability and the physical fractional change rattling in our pockets. We dove into the cognitive science of the left-digit effect, exploring how the rapid processing speed of our brains is actively used against us to alter our perception of value in stores.
And we conquered infinity.
Yes. Finally, we scare into the infinite limit of 0.999 repeating, using the laws of algebra to prove that sometimes what looks like a near miss is actually the entire whole.
It's a profound reminder that the symbols we use every day are never truly neutral. They are heavily loaded with human intention, biological quirks, and mathematical truths that defy our basic intuition. And, I'd like to leave you listening with a final lingering thought to mull over today.
Oh, please do.
We spent a lot of time discussing how heavily our minds are influenced by these just below numbers. We instinctively fall for the illusion of the bargain at 0.99. We are wired to accept the near miss because it feels economically safe. But where else in our daily lives are we being swayed by things positioned just below a threshold?
That is a fascinating way to frame it.
Think about your career trajectory, the boundaries in your relationships, or the personal goals you set for yourself. How often do we settle for the psychological comfort of the just below?
Wow.
Are we quietly accepting the metaphorical 0.99 in our lives, the almost good enough, the near miss, the slightly discounted version of our potential because it feels safe or like a bargain we can afford? Or are we willing to demand the full, complete 1.00?
Are we stuck holding on to the comfort of a terminating decimal, or are we going to demand the full exact picture? That is something to truly think about the next time you are standing at a cash register looking at a price tag. Thank you for joining us on this deep dive. We'll see you next time.